Okay, as promised, I would go over the data and how to record it for lab 3 so that you're kind of clear about where to put the numbers and you end up with the correct numbers in the proper place. So you started out by taking an empty graduated cylinder and massing it. And so in each case, the empty graduated cylinder is about 54 grams. And then to that empty graduated cylinder, you added in 10 mil increments 10 mils of water. So the first 10 mils of water you added, the mass went up to 64. So 64 minus the 54, and that's 10 grams. So the net mass of water is 10 grams. Then you added another 10 mils for a total of 20 mils. Now the mass went up to 74. So 74 minus 54, and so the net mass of water is 20. And similarly, you added another 10 mil portion, so now it's a total of 30 mils, and so the mass went up by 84. So 84 minus the 54, and that's 30 grams. Okay, so you have 3 samples of water, 10, 20, and 30 grams, and the volumes corresponding to them are 10, 20, and 30 as well. So the mils of water is 10, again 20 and 30, and the corresponding masses are 10, 20, and 30. And therefore, if you divide the mass by volume, you should get 1 gram per mil. And that's the density of water. So the average density of water is going to be 1 gram per mil. Now, in the next experiment with ethanol, again, the empty cylinder is always going to be the same, so it's 54. Now you added 10 mils of the ethanol. Now this time the mass went up to 61.8. all right, so when you subtracted the 54 from the 61.8, you get a mass of 7.8. In the second case, when you added another 10 mils, that's 20 mils of ethanol, and the mass went up to 69. So 69 minus the 54, and you get 15.8. Then you added another 10 mils for a total of 30 mils of the ethanol. So 77.7 minus the 54, and that's 23.7. So 10 mils of ethanol weighs 7.8. 20 mils of ethanol weighs 15.8, and 30 mils of ethanol has a mass of 23.7. So when you record that, you can see the 10 mils of ethanol, the mass is 7.8, 20 mils is 15.8, and the 30 mils of ethanol is 23.7. So when you divide the mass by volume, you should get about an average of 0.78 or 0.79. So you average this out and then write down the average density of ethanol. Now, in the third experiment, you took 30 mils of water and added it to the empty cylinder. So 30 mils of water should weigh about 30 grams. So 30 plus that 54, which is the empty cylinder mass, should come out to be 84 grams. So this is your initial volume and your initial mass. Now, what you will do for that next experiment with the iron is you are adding 5 grams of iron to that 30 mils of water, and so the volume will go up a little bit because the iron would have displaced its volume, so it went up to 30.64. So the volume of iron is 30.64 minus the initial volume, which was 30 mils. So the volume of iron is 0.64. All right. Mass of iron is 5. So 5 divided by that 0.64 will give you a density of 7.81. So it's the exact same thing here. Minus 31.27, minus 31.91, minus 32.54. All right. So you added iron in increments of 5. So the next total amount of iron is 10 grams. So 10 divided by the 1.27 and the density 7.87 and so on. 15 divided by the 1.91 and density comes out to be 7.85. 20 divided by the 2.54 and the density is 7.87. So the average should be in that ballpark of 7.86 or 87. So that's the density of iron. Now we come to aluminum, and here the volume after you added 5 grams of aluminum went up to 31.85. So 31.85 minus the 30, and the volume is 1.85. So 5 divided by the 1.85, you should get a density of 2.7. Again, 10 divided by the 3.7, you get a density of 2.7 and so on, right? So again, the exact same steps you would follow for the aluminum, and then average the density. Now you can omit this portion. If you wish to do that, you can do this, follow the instructions, and then use the graphing feature. Now this is optional. If you don't wish to do that, you can skip that part. And then you have to again record that initial volume of water, which is again going to be the 30 mils, and the initial mass would again be the exact same thing as before, 84 grams. Okay. And then what you're going to do is you're adding that unknown metal. Now they don't have that spot for 5 grams, they're going directly into 10. So 10 grams of the metal, and that volume went up to 31.4, so minus 31.40. So the mass of 10 divided by the volume of 1.4, and the density comes out to be 7.14. So in each case, mass divided by volume, and you should get an average of 7.14. And then you're going to use this value to identify the metal coming down here. All right, so you'll go again, you may not get that exact value as your measurement, but you'll pick the one that is closest in value and identify your unknown metal. Okay. And you'll write that down, and then of course complete your lab report, the aim for each experiment, your hypothesis, procedure, your observations, which is your data for each one of them, and then your results and your conclusions. Okay. Conclusions, whether in each case your hypothesis was supported, and then of course the real life applications of these experiments, especially what would be the real world examples of density, and how would this be important for you in the field of nursing. All right. Okay, so that's the end of this video.